Okay, good morning, everybody, and welcome to the last full week of classes for this semester. So, konti na lang, we are at the end. But before that, since medyo kulang tayo sa oras, I decided to record the lectures on three important results, namely the well-ordering principle, Zorn's lemma, and the axiom of choice. So hopefully you guys have already watched those three video recordings. Medyo hinati ko siya sa tatlo para hindi ganun ka heavy na buong 1.5 to 2 hours kayong manonood. So parang isipin nyo na lang siya na nagbi-binge watch kayo ng tatlong episodes ng paborito nyong Netflix series, right? So they are labeled the meetings at 23, 24, and 25 in our Canvas recording page. So kindly check them out. Don't worry if you haven't watched them yet. Medyo independent yung discussion natin today, so you can stay. But hopefully you'll find some time to watch those recordings para kompleto yung Math 101 experience nyo. And then today we will be counting down to the last few topics in the course. So today we'll be talking about Unit 6, which is Peano's axiom. So basically this is the development of, or the axiomatic development of the set of natural numbers. Tapos na natin yung PMI, so don't worry about that, nabawasan na siya. And then ang matitira na lang na topic, which hopefully we can tackle on Friday, would be equivalence, cardinal numbers, ordinal numbers, and so on, and probably levels of infinities. That's why I'm thinking to deviate a little bit from the work text and the study guide for Thursday's meeting. Siguro mag-freestyle na lang ako para ma-discuss ko yung konsepto ng cardinal, countable, and levels of infinity na rin, and probably touch on the continuum hypothesis on Thursday. So medyo mag-freestyle na lang ako doon. But today we'll still stick to the work text, and we'll talk about Peano's axioms, which would be, or which will tell us paano na develop yung set of natural numbers. But before going there, I already started grading problem set 3.1. Your lab instructors will grade 3.2. So for those early birds who submitted their works way before the deadline, na-checkan ko na siguro around 30 papers ng 3.1 yung na-checkan ko. Hopefully I can finish everything by tomorrow, if not siguro by Thursday. So that ready na ako uli para mag-grade ng problem set number 4. I was asking some of your classmates earlier if I have already told you when will I give you graded problem set number 4. According to the schedule, this will be given on the 20th until the 21st. So hindi ko matandaan kung nangako ako sa inyo ng earlier pagbibigay ng problem set number 4. So probably if you remember, you can remind me today. Pero para hindi lang 2 days yung paggawa niyo ng problem set, and I realized that or I acknowledge that probably you are also cramming some of the requirements for your other classes. So siguro ibibigay ko yung yung problem set number 4 earlier, probably Friday. Will that be okay? Bigay ko siya ng Friday, and then deadline ay, what's Friday? Friday is December 17th, if I'm not mistaken. Yes. And then the deadline would be on the 21st. Para medyo kung kailangan yung mag-sacrifice ng weekend, pwede niyong isama yung Math 101 dun sa weekend nyo. But I'll see to it that this will just be as short as the last problem set. So probably um, the first part will be an essay part. Ako yung mag-check, papa-explain ko lang sa inyo yung mga bagay-bagay. And then the second part will be a proving part consisting of 2 items, katulad ng problem set number 3. All right? And then we still have a final assessment, which will comprise 19% of your final grade. The final assessment will be due on the finals day, kung ano man yung isa-set sa atin ng registrar. But I'm thinking to put a definite date kasi wala pa. So siguro by January 10, ang gagawin nating deadline ng final assessment. So you can do it once you return from your holiday breaks. But kung mabore kayo during the holiday break, then you can start doing it. I'll give you the detailed guidelines probably on Thursday or on Tuesday. May meeting pa naman tayo ng Tuesday. Or pwede ko rin naman siyang ibigay sa Monday. Oo nga, Tuesday. Wala na palang klase ng Wednesday. Ano nga ba ang 21? 21 is a Tuesday, right? So, pwede pa tayo mag-meet next week to discuss the final assessment. Alright? So, doon ko ibibigay yung guidelines. Tapos ang deadline niya ay January 10, but you can submit earlier. Alright? Okay lang ba yung timeline natin na yun? Okay, so I hear no objections or violent reactions, so I guess we're good. So yun yung susundin nating timeline. Note ko na nga dito. Makakalimutin kasi ako sa dates, so siguro sulat ko dito ay this will be given on December 17 to 21. All right? Okay, so now we're ready to tackle the last, actually not last, siguro yung nakalagay na Unit 6 dun sa study guide, but this is Chapter 5 in the work text, and this is the construction of the set of natural numbers. So remember in math, we try to, or actually when you're doing your majors, you will find out na parang sa major classes, nire-reconstruct lang natin formally yung mga bagay-bagay na alam na natin from the beginning. So, for instance, when you go to Math 155, you will go over the concept of limits, derivatives, integrals. And these things are things that you already know from Math 36, 37, and 38, and even from your senior high basic calculus classes. So, na-encounter nyo na sila, ang gagawin nyo sa major math courses nyo, babalikan nyo siya at titingnan nyo bakit nag-work yung mga bagay na yon. Or bakit ganito yung definition ng limit, bakit ganito yung definition ng integral, and so on. And how they are formalized or developed axiomatically. So parang i-rebuild nyo from scratch yung mga konsepto na natutunan nyo. And that same thing ay gagawin na natin dito sa Math 101. Sisimulan na natin siya with a very important notion, which is the set of natural numbers. In the next hour or so, we'll be looking at how the set of natural numbers were developed axiomatically. So parang set theory lang yan. Nagsimula yung development ng natural numbers since the ancient Babylonians and some other earlier civilizations na from the beginning they're using natural numbers to count their goods, right? So kasi doon naman na-develop yung mga numbers. They arose out of necessity. So nung mga hunters and gatherers pa yung mga tao, they need to come up with a way on how to keep track of their produce. So ilang baka na ba yung meron sila, ilang repolyo na yung na-harvest nila. So kailangan nila ng numbers na magsisymbolize dun sa quantity ng mga produce nila. And little did they know that that concept of numbers that they have developed for that very menial task ay yung tinatawag natin na set of natural numbers. And this was continually used until modern times at until ngayon ginagamit natin yung mga natural numbers pambilang. Pero with the drive of axiomatizing mathematics, inisip ng mga mathematicians paano na-construct yung set of natural numbers. Although, kaya nga natural yung tawag sa kanya, the development came out naturally out of necessity, ano or paano natin siya bibigyan ng clear and solid mathematical foundation. So kung matatandaan nyo, parang Cantorian set theory. Si Cantor, though may axioms na siya, yung set theory niya ay more on the intuitive side. Pero dumating si Sir Melo Frankel, finormalize nila ito by using some axioms. So ganun din sa set of natural numbers. Alam na natin siya from before, but for the next hour or so, I will ask you to forget about the set of natural numbers. Mahirap kasing pag-aralan yung set of natural numbers if you already have a bias about it or if you have an idea about it. Yun yung mahirap sa mga major courses kasi kailangan i-unlearn nyo muna yung mga bagay na alam nyo na before. Tapos kasi papalitan natin siya ng isang mas axiomatic na understanding about these concepts. So, kalimutan nyo muna. Kunwari, wala pa kayong alam na set of natural numbers. I will try my best to try to reconstruct it for you. All right? So, and then the reconstruction, of course, since it's a mathematical reconstruction, will involve a choice of axioms or self-evident truths that will be assumed for the sake of the construction. All right? Tapos, makikita nyo kung bakit siya tinawag na natural numbers. So, sabi nga ni Kronecker, although si Plato yung sinite dito, but I think this quote is more relative. This is more popularly attributed to the mathematician Kronecker. Sabi niya, God created the natural numbers and the rest by man. Medyo pwede nating susugan yung quote ni Kronecker. Makikita niyo mamaya na pwede pala itong palitan na God created zero and the rest followed. Right? So titingnan natin kung bakit. So for today, we'll define what a natural number is, look at Peano's axioms and its implications, and then probably touch on simple arithmetic of natural numbers using the axiomatic notion of natural numbers. And then tapos na tayo sa part D, so that's one thing off our list kasi nagawa na natin yung PMI when we went to methods of proof. Okay, now let's look at the definition of the natural numbers. Well, as promised, the development of infinite sets, such as the natural numbers, though hindi ko pa na-define kung anong yung infinite, right? Pero meron tayong axiom of infinity mula dun sa ZF axioms natin for set theory. And if you recall, we called it ZF6. Ang sabi niya, there exists a set A such that the empty set is an element of the set A, and if X is an element of A, then X union the set containing X is in capital A. So it means that there is an infinite set. All right? Ibig sabihin, merong set na napakarami yung laman. I mean, we cannot write all of its elements terminally. Kasi pag meron kang element, manganganak pa yun ng isang element and so on. So basically, the existence of infinite sets, such as the set of natural numbers, is guaranteed or is allowed in our set theory by ZF6. All right. Now, titingnan natin kung paano itong ZF6 ay naging responsible para sa development of natural numbers. At dadaanin natin to by the development by using the successor relation. Okay, and that's in definition 2. So let's consider a set capital X. It could be any set, so it's an arbitrary set. And then we say that the successor of the set X denoted by X plus. All right? So meron kang set X, tapos mula kay set X, makakapag-define pa tayo ng panibagong set. Ang tawag natin doon sa panibagong set na yun ay yung successor ni X. Kaya ang sabi ko ngayon, yung isang set nanganganak ng nanganganak, yung ipinanganak niya, ang tawag natin sa kanya ay successor. Alright? Tapos ang notation natin sa kanya ay X plus. Si X plus, siya yung successor ni X. And X plus is defined in this way. X plus is the union of the set X and the set containing X. And this form looks familiar. This is basically what this ZF6 is telling us, na may nag-exist na set ng itsura ay X union set containing X. Alright? So, ang tawag natin doon ay yung successor ng isang given na set. Alright? And then, a set A is a successor set, even only if this is true. Right? So, meron kang isang set, tapos madidefine natin ang successor ng kahit anong set using this equation. Now, if we will collect several sets, that collection of sets, say capital A, ay isang successor set. Kapag kumuha ako ng isang element nung successor set or nung collection ng mga sets na yon, and it will imply that the empty set is in the collection and the successor of the set X is in the set A. So yun yung tinatawag natin na successor set. So medyo dalawang terminologies yung dinidefine natin ngayon. So nagsimula tayo sa isang set X. Kahit anong set X. Pwede natin i-define yung successor niya to be X plus, which is X union the set containing X. Tapos ngayon, ang isang family or isang collection ng mga sets ay tinatawag na successor set. Kapag si empty set ay nandun sa family, at kapag meron akong X dun sa family, yung successor niya ay nasa family din. So basically, yung isang successor set, ang existence niya ay ginaguarantee ng ZF6. Alright? So basically, pag meron kang set, family of collection of sets, nandyan daw si empty set. Alright? Tapos, para maging successor set si curly A, dapat yung successor na mga laman niya ay na kay curly A din. Eh, alam ko si empty set na kay curly A. So, dapat yung successor ni curly A ay yung successor ni empty set ay na kay curly A. So, dapat andito yung successor ni empty set. Pero anong itsura ng successor ni empty set? Ang successor ni empty set is defined to be the empty set union the set containing empty set. Eh, ang union ng empty set together with any other set will just be the other set. So, siya lang ay set containing the empty set. So, pwede ko siyang palitan. Sulat ko siya ng ganito. Tapos, meron na naman akong panibagong laman ng family curly A. Siya ay si set containing the empty set. So, sabi nung definition ng successor set, para si curly A ay maging isang successor set, yung successor ng laman niya dapat nasa kanya rin. So, kukumputing ko ngayon, ano yung successor ng set containing the empty set? Well, by definition, this is just the set containing the empty set union the set containing the empty set. Alright? Kasi kung mapapansin nyo, si X, i-union mo dun sa naka-brace na X. So, ito ngayon yung X ko, ilalagay ko siya sa loob ng braces, yun yung ipapang-union ko. Alright? And then if we take this union, this will just be the set containing the empty set and the set containing the empty set. And according to the definition of a successor set, this guy must also belong to the set curly A. Tapos ngayon, si curly A, naging laman niya yung set containing the empty set and the set containing empty set. Now, for curly A to be a successor set, it must also contain the successor of the recently added set. Ito pala yung recently added set ko na yan. So, kukumputing ko na naman yung successor nito, mapapalagay siya kay curly A, tapos napalagay siya kay curly A, so yung successor dapat ay nandun din kay curly A. Kaya yung Z of 6 talaga, axiom of infinity, kasi hindi tayo natatapos ng pagdadagdag ng mga elements dun sa successor set curly A. Right? So basically, in the current parlance that we are developing, we can say or we can restate Z of 6 to simply mean that there exists a successor set. All right? Yun yung basically sinasabi ng Z of 6. Now, if we will partially or the set of all successor sets can be partially ordered with the inclusion relation. And by a tedious application of probably Zorn's lemma, we can say that there exists a unique minimal successor set. So kung ililista natin or kokolektahin natin lahat ng mga posibleng successor sets, idodrawing ko yung poset diagram niya with the inclusion relation. May makukuha kong unique na minimal successor set. All right, with respect to inclusion, and we will call this the set omega or little omega. So itong omega na to, siya yung pinakamaliit. When I say pinakamaliit, I mean ito yung minimal successor set. Sa poset diagram, wala nang nasa ilalim pa ni omega. Alright? Si omega ay pwede mong computin to be the intersection of all the successor sets in the family. Tapos makikita natin mamaya, etong si omega, siya yung set of natural numbers. So you can think of it na, okay, si omega, na ito yung parang primitive na pangalan para sa set of natural numbers, siya pala yung unique minimal successor set. Sa una, isa siyang successor set, tapos hindi siya superset ng kahit ano pang successor set kasi siya yung minimal. So, if you think about it, pinakamaliit na posibleng successor set pala si omega. Tapos si omega mamaya malalaman natin siya yung set of natural numbers. Tapos di ba any successor set will satisfy Z of 6. So pwede mong isipin, so ibig sabihin, si natural numbers, so si set of natural numbers, which is now called omega, or for now called omega, siya yung may pinakamaliit na level ng infinity. Yan yung titingnan natin sa Thursday. Pero yun nga, siya yung minimal successor set, so siya yung pinakamaliit in terms of inclusion. So if you think about it, siya rin yung may pinaka-counting element which pwede kong i-connect for Thursday's discussion. Siya yung may pinakamaliit na level of infinity, right? Now, actually, the development of the set of natural numbers or the set omega for now is basically naumpisahan ko na siya dito sa pagko-construct nitong set na to. Kasi siya yung pinakamaliit or siya yung minimal na successor set. So ano yung sure tayo kasi kailangan kong i-construct si set of natural numbers to be the minimal. So ito yung pinakamaliit na successor set. And in my development of curly A here, I tried to be as minimal as possible. So kasi para maging successor set, dapat si empty set at least ay nandun sa successor set. So kaya nilagay ko si empty set. Tapos ayoko magdagdag ng sobrang mga elements kasi tinatry ko nga i-construct si omega. So tawagin na natin tong omega. Right? Tinatry kong i-construct si omega. Siya dapat yung pinakamaliit. So, hindi ako magdadagdag ng mga unnecessary elements dito kasi gusto ko siya yung maging minimal. So, a successor set should at least contain the empty set. Tapos, ang requirement, kapag ka-element ka ng successor set, yung successor mo ay nandun din dapat sa successor set. So, kinompute natin yung successor ni empty set. Siya na yung set containing the empty set. Tapos, kinompute ko yung successor nito. Ito yung nakuha ko. And then what I'll do next is to calculate the successor of this set. Kasi dahil na kay omega siya, yung successor niya dapat malagay din kay omega. Tama? Pero ito ay, ano yung successor niya? Sarili niya. Union, yung set containing yung sarili niya. So be careful with the grouping symbols, alright? So parang ito, nilagay ko lang siya sa loob ng braces. Alright? Tapos pag kinuha ko yung union nito, magkakaroon ako ng empty set containing the empty set, then set containing the empty set, and the set containing the empty set. Ito yung successor niya. Hopefully, I am not missing or adding any excessive braces. So ito yung malalagay dito. Okay. Tapos magkakaroon ka pa ng mga dagdag na elements dyan. Kasi nanganganak yung mga elements ng successor set. Alright? But you see that writing the set omega this way is very tedious. Mahirap isulat kasi ang daming braces na involved and so on. Kaya mag-iimbento tayo ng symbols para sa bawat isang element ni omega. Tapos yung mga symbols na yon, sila yung tatawagin nating mga natural numbers. Okay? So si empty set, tatawagin ko siyang 0. Okay? Now, of course, the choice of the symbol 0 is kind of arbitrary here. Okay? So, pero pwede mo siyang isipin, ilan ba, or in our current intuition, ilan ba yung laman ni empty set? Wala siyang laman, so sige, tawagin ko siyang 0, and that's why 0 stands for nothingness, or sa pagkakaroon ng walang laman. Alright. Tapos, yung successor ni empty set, dahil nga si empty set as a natural number, sinusulat natin as 0, pwede ko itong palitan ng 0. Kasi nga si empty set ay 0. So lahat na nakikita yung empty set dito, pwede kong palitan ng 0. Okay. And so on. So, yeah. Mabubura kasi yung mga braces. So, ganyan yung mangyayari. Papalitan ko lang sila ng puro 0. Tapos, yung pangalawang element ni omega ay set containing 0. So, isang set, yung pangalawang laman, ilan yung laman nitong set na to? So, meron siyang isang laman, o sige, tawagin ko siyang 1. Okay. Again, the choice of the symbol 1 is kind of arbitrary. So, kung talagang sinisimulan natin to from scratch, pwede kayo magbigay dyan ng symbol na apple or banana, symbol na star, symbol na sun. Pero, tatawagin ko siyang 1. Trip kung tawagin siyang 1 eh. Pero this goes well in hand with what we already know na ano nga yung original dito? Set containing 0. Ilan yung laman ng set na yan? Isa yung laman niya. Ang laman niya ay si 0. Alright? So kaya tawagin ko na siyang 1 to borrow what we know from our elementary grades. Tapos yung susunod na element. Susunod na element ng successor set ay set containing 0 and set containing 0. But again, we replace the set containing 0 by the symbol 1. Okay? Tapos, titingnan ko ano kaya yung magandang symbol para sa set containing 0, 1. Yung set containing 0, 1, meron siyang dalawang laman. So basically, tawagin ko na lang siguro siyang 2. And so on. If we go here, meron siyang tatlong laman. Set containing empty set, set containing the empty set, and the set containing the empty set, and the set containing the empty set. So meron siyang tatlong laman. 1, 2, 3. So tatawagin ko na lang siyang 3 para hindi ako mamroblema dun sa mga braces. Okay? And again, the choice of these symbols are kind of arbitrary, but this comes hand in hand with our usual use of the counting numbers or the natural numbers. Okay, and that's how nabuo yung set of natural numbers. So nakita nyo, talagang abstract notion lang yung numerals o yung mga numbers. Actually, natural number stands for sets. Sila yung mga sets na laman ng minimal successor set. Right? So that's how it is constructed. So ito yung ito yung objects of our discussion. Now we have the terms, we have the undefined terms here. Hindi sila mga undefined terms, pero given terms sila. Ito yung mga terms dun sa ating dine-develop na theory of natural numbers. Then let's look at what are the axioms that will govern the set of natural numbers. Okay? Aside from the axioms of set theory, specifically CF6, ano pa yung mga gusto nating maging properties ng set of natural numbers? Ano yung mga rules of the game in our construction of the set of natural numbers? Well, we have 5 axioms concerning this natural numbers or the set omega, and these are called Peano's axioms. But Peano's axioms are actually are formulated technically by Dedekind. So that's why most people called it the Dedekind Peano's axioms. Pero in literature, usually it's just called Peano's axioms. Now, ano dapat yung mag-govern doon sa set omega natin and the successor relation? Okay? So if we take the successor relation together with the minimal successor set omega, which we define to be the set of all natural numbers, ito na yung set of natural numbers natin. But again, at the back of our minds, the number 0 is the empty set. The number 1 is the set containing the empty set. The number 2 is the set containing the empty set and the set containing the empty set, and so on. So ano yung mga rules na gusto nating mag-govern sa mga natural numbers na yan para ma-preserve natin yung mga alam nating totoong bagay tungkol sa mga natural numbers mula pa nung elementary. Okay. Peano's axiom number 1. 0 is an element of omega. So kaya napilitan ako na isama si 0 sa set of natural numbers. Remember when we started PMI, sinama natin sa natural numbers si 0. But some text starts the set of natural numbers with 1. Which is fine kasi isipin nyo lang na si 1 yung symbol nila para sa empty set. Alright? Kasi again, the notion of numbers are just abstract. The choice of symbols are just arbitrary. Alright? So it doesn't matter kung simulan mo siya sa 0, simulan mo siya kay 1. Kasi ako nga sa outside of math 101, laging 1 yung simula ko ng set of natural numbers. Pero for now, let's use this version of Peano's axioms and consider 1 to be the set of to be the first element of the set of natural numbers omega. All right? Kasi mas natural dito yung paggamit ng 0 kasi ito yung dami ng empty set na nire-represent ni 0. All right? Now, second Peano's axiom, if n is in omega, then the successor of n is in omega. So parang ano lang to, following the very definition of omega being a successor set. Okay? So yun nga pala dito sa Peano's axiom, o sa Peano's axioms, kinalimutan niya yung konsepto ng successor. Kasi yung diniscuss natin konsepto ng successor at successor sets, kung saan natin nabuo yung omega, alright, ay independent dito sa Peano's axioms. So, yun yung parang intuitive development. So, yung development ng successor set, tapos omega being the minimal successor set, sila yung intuitive or yung naive construction ng set of natural numbers. Kasi kung mapapansin nyo, parang dito pa lang sa discussion natin about omega, yung pa lang sa definition ng omega being the minimal successor set, na-construct na natin yung set of natural numbers, alright? But we want to axiomatize this, meaning we want to lay down what are the axioms that governs the behavior of these natural numbers. Doon papasok si Peano's. In-axiomatize nila itong construction natin kanina by laying down 5 self-evident truths to be assumed for the set of natural numbers. Okay? Ito yung intuitive version, ito yung axiomatic version. Nag-start tayo sa 0 being an element of omega, and this is the same thing as our assumption that in a successor set, the empty set must always be a member. So, dun siya papasok sa Peano's axiom number 1. Peano's axiom number 2, if you have an element of omega, then its successor is an omega. So, ito yung parang nasa definition pa rin siya ng successor set. So basically, P1 and P2 just formalizes the definition of the successor set. Kasi makikita nyo dito yung plus sign ay hindi sinabi siya yung successor relationship. Sinabi isa lang siyang unary operation. When we say unary operation, isa lang yung argument niya. So hindi siya katulad ng binary operation like addition na dalawa yung pinag-a-add natin. Sa unary, kailangan mo lang ng isang object tapos pwede mo sa kanyang i-apply si plus. So si omega plus or isang element ni omega plus ay well-defined element of omega. Right? And how do we define n plus? When n is an element of omega, it must be another element of omega. So basically, ito yung nanggaling sa definition of a successor set. Okay, so it's as if using P1 and P2, marireconstruct na natin yung omega na binuo natin kanina intuitively. But again, just using these two axioms might lead to some paradoxes. Katulad, di ba, kung naalala nyo yung naive Cantorian set theory, meron lang siyang tatlong axioms, tapos hindi nila napansin na kulang yung tatlong axioms. Hindi nila napansin yon hanggang dumating si Russell, kung saan binigay niya yung Barber's paradox. So to avoid inconsistencies within the set of natural numbers, kulang pala yung P1 at P2. Kulang yung notion ng successor set. Kaya kailangan pa nating idagdag yung susunod na tatlong Peano's axioms. Yung pangatlo, the successor of n, yung plus sinatawag ko na pala siyang successor, the successor of n cannot be zero for any element of omega. So si 0 ay hindi successor ng kahit anong natural number. 0, parang pwede nyo isipin si 0, siya yung first element ni omega. Kasi never siyang magiging successor ng kahit na ano pang element ni omega. So siya yung parang ninuno ng set of natural numbers. Kaya sabi ko kanina, yung quote ni Kronecker, pwede nating isipin na God created 0 and everything else followed. Alright? Thanks to Peano's axioms. So, yeah. So Peano's axiom number 4, this says that the successor is unique. If you have two successors being equal, then their predecessors must be equal. So kung si M successor ay equal kay N successor, dahil unique nga ang successor, dapat si M at saka si N ay equal sa isa't isa. Alright? So basically, P4 summarized, unique lagi ang successor. Hindi pwedeng dalawang magkaibang successor o dalawang parehas na successor para sa magkaibang numbers. So pag naging successor ka na ni M, hindi ka na pwedeng maging successor ni N unless si M ay equal kay N. Alright? And then look at the axiom number 5. And then tingnan nyo kung matatanda nyo kung saan natin na-meet yung P5 na yan. Can anyone remember? Ano yung kamukha ng axiom number 5? So sabi niya, if a subset B of omega is a successor set, then B is equal to omega. Now, P5 just emphasizes that omega is the minimal successor set. Sinabi natin dun sa ating naive construction kanina na si omega, siya yung unique minimal successor set. So, kailangan natin yung ilagay sa axioms natin. Nilagay siya dito. If a subset B of omega is a successor, so ibig sabihin si B nasa ilalim ni omega dun sa poset diagram, kasi si B ay subset ni omega, tapos si B ay successor set then necessarily si B dapat ay equal kay omega. Kasi gusto natin si omega, siya na yung maging minimal successor set. Okay? And then our statement of this statement is this. If B is a subset of omega, such that 0 is in B and the successor of M is in B, whenever M is in B, then B is equal to omega. So, etong P5, siya actually yung foundation o siya yung reason kung bakit may principle of mathematical induction. Alright? Kasi makikita nyo, 0 is in B. So, pwede nyo isipin si B to be the set of all numbers satisfying property P. Okay? So, isa siyang subset ni omega kung saan laman niya lahat ng numbers na nagsasatisfy ng isang property P. Tapos tingnan niyo itong assumption nito. Si 0 is in B. So, ibig sabihin si 0, dapat sinasatisfy niya yung property B. Ito ay yung basis step ng PMI. Okay? Tapos, M is an element of B. So here we are assuming that M satisfies the property B. So ito yung hypothesis of induction. Tapos gusto nating i-prove na kung si M ay na kay B, dapat yung successor ni M ay na kay B rin. Ito yung induction step. Yung ginagawa nyo nun na assume that P of M is true, yun yung HOI. Then from there, we want to show that P of M plus 1 is true, then yun yung induction step na sinasabi natin. Tapos, pag napakita na natin yun, sinasabi natin by the principle of mathematical induction, the theorem is true for all natural numbers. Yun yung conclusion na B ay equal kay omega. Kaya usually, sa mga books, dinidefer nila yung discussion ng principle of mathematical induction pagkatapos ng Peano's axioms. Kasi nga yung reason behind the PMI ay yung fifth postulate or yung panglimang axiom ni Peano. Alright? So, yeah. Any questions about the development of the set of natural numbers? Medyo ano ba siya? Medyo foreign. Medyo out of this world. Kasi ito nga yung mahirap eh. Alam na natin from the beginning ano yung natural numbers. Tapos ngayon, in-unlearn natin siya, sinira natin yung konsepto natin ng natural numbers, pinalitan natin ng mga successor. So ngayon, pag nakakita kayo ng natural numbers, isipin nyo, hindi yan natural number 1. Yan yung set containing the empty set. Alright? So pwede pala pag nagbibilang kayo, instead na 0, 1, 2, 3, 4, pwedeng empty set, set containing the empty set, set containing the empty set, and the set containing the empty set. Tapos yung 4 nyo ay yung 3 nyo ay set containing the empty set, the set containing the empty set, and the set containing the set containing the empty set. All right, that's going to be our number 3. All right, pero that is necessary in order to give a solid mathematical foundation free from paradoxes para sa set of natural numbers. Tapos ito rin, yung konsepto na yan, yung mga axioms na yan ni Peano, yan din yung ginagamit o yan yung ginamit natin para i-justify yung mga basic properties natin for natural numbers. Halimbawa, gusto mong i-prove na 0 plus A ay equal kay A for any natural number A. Well, with just an intuitive notion of natural numbers, parang sabihin mo, hindi pa na yan kailangang i-prove kasi napaka-basic niyan. But actually sa math, kailangan natin ng mga proofs sa lahat ng mga statements aside from the axioms. So, ginamit itong development or itong axiomatic development ng natural numbers in order to reconstruct or to prove the basic notions or the basic properties for arithmetical operations on the set of for the set of natural numbers. Yan yung nasa section 5.2. However, the proofs are very technical na hindi na natin siya isasama dito sa discussion pero ang idea ay nandun pa rin siya. Gagamitin nyo lang yung axiom number 5 along with the definition of successorship and the other Peano's axioms to prove yung mga basic properties ng arithmetic on the set of natural numbers. So we will not go by the proofs. So kung curious kayo, reading assignment na lang siya. But for math majors, and I think MSc majors also take Math 103, babalikan nyo uli yung Peano's axioms, dun nyo ipoprove na commutative ang addition, associative ang addition, and so on. All right? Now, the first few results deals with addition. All right? So yung addition sa Theorem 5.2.1 ay tinago sa pangalan na alpha. Si alpha ay isang function from n cross n papunta kay n. So it takes two natural numbers, tas dinadala niya yung pair ng natural numbers na yon sa isa pang natural number, satisfying two properties. The first property is that alpha of 0n ay equal kay n. So parang ano siya, 0 plus n ay equal kay n. Tapos for any natural numbers m and n, right? Alpha of the successor of m, comma n ay equals sa successor ng alpha m, comma n. Right? So ang idea rito ay ito yung formal parang treatment ng addition. So yung to simplify notations, yung alpha of 0n, tatawagin na lang natin siyang 0 plus n. Tapos ang value assigned natin para kay 0 plus n, according to theorem part 1, ay equal lagi kay n. So ito daw ay unique property ng set of natural numbers together with the next one, na ang sum ng successor ni m at saka ni n ay equal sa successor ni m plus n. So yan yung sinasabi ng theorem 5.2.1. Essentially, ang sinasabi ni theorem 5.2.1, nag-iisa lamang yung operation na nakakasatisfy nitong dalawang properties na to ng sabay. And that operation is what we knew to be addition. Kasi addition lamang ang katangi-tanging operation na nakakasatisfy ng dalawang properties na yan. Alright? So siguro tingnan natin kung paano nag-work yung definition. Say let's compute, okay, so first let's assume that 1 is the successor of 0. Right? Pero ito na yung ginawa nating symbol kanina para sa successor ni empty set, right? The set containing the empty set is the successor of the empty set, and we will denote that by 1. Right? Tingnan natin yung a plus 1. Anong itsura ng a plus 1? So let a be an element of omega. Pero ito yung isang problem ko sa work text. Mabilis yung transition niya mula kay omega pupunta kay n. So isipin nyo na lang si n is the same as omega. Pagka ginamit natin sa omega, ang usual symbols na ginagamit ay yung mga sets. Empty set, set containing the empty set, and so on. Pag ginamit na natin yung symbols na 0, 1, 2, 3, 4 para dun sa mga sets inside omega, tatawagin na lang natin siyang capital N. Alright? So kung si a ay natural number, isolve natin yung a plus 1. Or siguro, wag a plus 1. I-compute ko yung 1 plus a. Alright? Now, 1 plus a can be written as successor of 0 plus a. Alright? By definition of 1 being the successor of 0. Parang symbol natin sa successor ni 0, C1. Alright? Tapos, using Theorem 5.2.1.2, gagamitin ko ito, meron akong successor plus another natural number, ang sagot daw ay successor nung sum ng dalawang numbers without the successor. So, ibig sabihin nito, by that second property, pwede kong isulat na tatanggalin ko yung successor dun sa 0 plus A, nakasuccessor siya sa labas. Alright? So, ginamit ko yung property 2. And then, I will use property 1. Ito naman yung gagamitin ko. 0 plus A will be equal to A. Alright? Kasi walang effect daw yung pag-add ng 0. So, this will become a successor. So, kaya kaya napaka-handy nung addition dun sa konsepto ng successorship. Kasi yun pala, kapag ka nagdagdag ako ng 1 sa isang natural number, ang magiging sagot ay yung successor niya. And that's why our notations for the elements of omega now make sense from the point of view of the set of natural numbers that we know before. Kasi halimbawa, gusto kong i-define yung successor ni 1. Alright? Ano kaya yung magandang symbol para sa successor ni 1? So, si successor ni 1, siya lang pala yung 1 plus 1. Kasi si 1 successor ay si 1, dadagdagan ko lang ng isa. Or si 1, dadagdagan ko ng 1. Kasi nga, yung A successor ay 1 plus A. Si A ko dito ay 1. So, magiging 1 plus A. So, alam natin ang 1 plus 1 ay equal kay 2. Kaya napili kong symbol para sa successor ni 1 ay equal kay 2. So, kung naghahanap ka naman ng symbol para kay 2 successor, si 2 successor ay equal kay 1 plus 2, right? Kasi yung successorship, nag-add ka lang ng 1 sa simula. Tapos, alam na natin from elementary that 1 plus 2 is equal to 3. That's why we say the successor of 2 is assigned to the symbol 3. And so on. So, parang weird, no? Parang, alam na natin yung 1 plus 1 equals 2. Yung pala ni 1. So, tapos 1 plus 2 ay equal kay 3 kasi pala si 2 ay successor, si 3 ay successor ni 2. And so on. Alright? So, this kind of analysis can be used together with P5, or the principle of mathematical induction, to prove the following properties of addition. Addition is associative, addition is commutative, cancellation laws apply. Tapos, kapag ka si m is less than or equal to n, then we can find a natural number n that should be added in order to reach n. Okay. And then this is the addition property of inequality. And then here, if you add two natural numbers, the answer is 0, then the two numbers must be both equal to 0. Okay. Again, we will not we will not prove this 6 properties here, but the proof will require you to use the concept of successorship together with the principle of mathematical induction. Don't worry, hindi ko naman yan ipapaprove sa inyo sa klase. Kasi parang, saan ko nga ba ito pinrove? Nung undergrad ako, which is not too long ago, alright, kunwari. So, pinaprove sa amin ng prof namin yung associativity. And I think my proof for associativity ay umabot ng 3 or 4 blue book pages kasi pinrove ko siya line by line, ginamitan ko ng successor, ng successor, ng successor, tapos ginawa ko pa yung pakabila, in-expand ko rin to using yung mga successor relations ng PMI, tapos sa dulo pinakita ko sila equal sa isa't isa. Yung tuloy, pati yung back cover ng blue book ko ay may sulat na rin kasi napuno na siya ng mga proofs, right? So, yeah. We will defer the proofs of this, guys, to your major courses. Maybe it would be on 103. Ngayon sa 155, hindi na namin pinuprove or di na namin dinidiscuss yung natural numbers. So, yeah. Siguro sa 103 nyo na yun makikita. Okay. And then, similarly, you can devote or you can construct in the same manner multiplication on the set of natural numbers, and its properties are enumerated in Theorem 3. Sinasabi ng Theorem 3 dito, nag-iisa lamang yung function mu. Alright? Ano si function mu? Define siya sa n cross n. So it takes two natural numbers and assigns it to another natural number. And then, nag-iisa lamang yung function ng mu that satisfies these two guys. Ano yung sinasabi niya? Mu of 0 and n is equal to 0. And then, mu of the successor of m, comma n, is mu of m plus n plus capital N, plus the value of n. So, ibig sabihin, kunin mo muna yung parang product ni m at saka ni n, tapos idagdag mo sa kanya si little n. Right? Bakit ito nag-work? Well, binigyan natin siya ng symbol kasi nag-iisa lang naman daw yung function mu, tawagin natin siyang multiplication. So in property number 1 will be of the more familiar form that we know 0 times n ay equal kay 0. Right? So, isa siyang property ng multiplication talaga. Tapos yung property 2 can be translated this way. Si m plus times n. Pero remember, si m plus, alam na natin siya to be m plus 1. By the computations we did before, na ang successor ng isang number pala ay yung number na yon plus 1 lamang. So ito ay maging m plus 1. Tapos ito ay equal kay m times n plus 1. Using the good old distributive properties that we know, all right? Pero dito hindi pa natin alam yung distributive loss. Pero parang properties lang siya ng multiplication. So, tas mapapansin nyo, ito ay m times n, yan yung mu of m comma n, tapos may plus n ka pa dito sa dulo. Right? Kaya property 2 kind of makes sense. And then theorem 5.2.3 actually claims na nag-iisa lamang yung operation, yung binary operation mu that satisfies these two guys. At yun yung tinatawag natin na multiplication. All right? And then again, we will skip the proof, but it could be shown that multiplication satisfies the following properties. It is associative, meaning the grouping doesn't matter. Commutative, the order doesn't matter. Cancellation law applies, but there's a little caveat here. P is not equal to 0. Yung pinang-divide mo, pinang-multiply mo both sides, dapat ay hindi equal kay 0. And then the distributive property of multiplication over addition, which I prematurely took advantage of para i-explain sa inyo yung property number 2. Tapos, you have multiplication property of inequality here, and then the zero property. If you multiply two natural numbers and the answer happens to be 0, then either the first factor is 0 or the second factor is equal to 0. Okay? But again, we will not dwell with the proofs. These are beyond the scope of this class. Pwede rin naman, pero medyo hindi na siya appropriate gawin dito dahil wala na tayong oras. And essentially, you will see these again in other courses. But I guess that's the construction of the set of natural numbers, and we're just about 2 minutes over time, which I think is good. So on Thursday, I'll talk about cardinality, equivalence, and the concept of infinities. If I won't be able to finish everything by Thursday, probably I'll record something for you to watch over the weekend para kompleto pa rin yung Math 101 experience nyo kahit hindi natin na-discuss sa klase lahat ng mga konsepto, but I don't want to turn any stone unturned. So kaya, yeah, worst case, magre-record ako ng discussions para dun sa mga natitirang topics. But I'll try to squeeze everything in by Thursday. And then your fourth problem set will be released on Friday. The deadline would be on Tuesday next week, right before deadline, the last day of classes. And then what else? Okay. And then the details for the final assessment, which is equivalent to one problem set. Kaya kailangan yung seryosohin yung final assessment. The deadline is January 10. Tama nga ba? January 10 yung sinulat ko kanina. And then the guidelines will be discussed on Tuesday next week. All right? So that's it for today. Do you guys have any questions, clarifications, suggestions?
Sir, may ask po ako after po.
Sige, sure. Mitzi, how about you?
Sir, average ng prob set 4?
Problem set 4, mag-start siya sa after ng functions. Anong after ng functions? Hindi ko na rin tanda. Mahina ang memory ko eh. After functions, after partitions, basta after na. Tingnan ko, double check ko. Oh, it will be about posets. So start sa partial order hanggang sa Peano's Axioms. Or hanggang ano pala, hanggang dun sa i-discuss natin sa Thursday. So simula sa partial ordering hanggang dun sa i-discuss natin on Thursday. Plus possibly the video recordings. Alright? So, pero don't worry, maiksi lang din siya. Parang problem set 3 lang. So, isang essay question consisting of subparts, tapos 2 proving problems, yun yung second part. Okay? All right. Any other questions? All right, if none, so thank you guys for coming today. Enjoy the rest of the day. Tas kita-kita ulit tayo on Thursday. Bye, everyone.
Thank you po.
Thank you, sir.
All right.
Thank you, sir.